In this video, I'll briefly go through how to apply the proper and strictly proper so-called pole placement system. Alright, I'll just briefly describe. So let's start. So before we can design your controller, what do we need to know first? You need to know the transfer function of your plant first. Alright, and therefore after certain trial and error, we decided that the plant's transfer function is 1 over s squared plus 2. Okay, it's a simple plant. So b naught s is equals to 1. Alright, what is the order? The degree of order is equals to 0. As for a of s, what is the order of this? This part over here, this is the a of s. This part, the degree is actually highest is square. So in other words is 2. Alright, so I just write it as 2 over here. So this is for the a naught, this is for the b naught. So far, so good. Alright, and therefore this is my first step. Alright, just rewrite everything so that it's neater. Alright, and the highest order of your transfer function is the n. Alright, so the highest order is 2, so therefore n is equals to 2. Okay, so for proper system, alright, you can sub in over here. So when 2 minus 1 is equals to 1. So your controller's transfer function must be your some degree of 1 order of degree. And therefore I just rewrite this as G1, alright, S1, because it's a first order, I mean 1 order, 1 degree of order, or whatever order, macam, and then G2, or G0, alright, let's just write G0. Alright, and your H over here is also the same thing. But however, if you remember, your H is a monic system. Remember, the coefficient for your highest order should be just 1. Same thing as for your A. Alright, so please take note of this. So therefore, I'll just simply write as S plus H1. Alright, where S0 is just simply H1. Alright, well, S0 is just equals to 1 now, okay? So you can remove 1 because it's just simply saying that it's S to the power of 1. Alright, so just not to confuse you. Alright, so I'll just simply cancel away this one. So it's G1S plus G0. Alright, so it's some constants that we are keen to find. So I've already set up our transfer function for our control already. This is the configuration. We just need to know what is H1, what is G1, and what is G0, and that's it. So how do we do it? We know that we have found this already. Therefore this is the second step. Alright, the third step is to sub in to your this thing over here. So your n is equals to 2, so you have equals to 3 now. Alright, so your degree of your ACL or your Diophantine, whatever Fantin equation is this with of this order. Highest order is 3. Okay, so therefore I'll just write out my Diophantine equations, which is A naught H. Alright, so this is your Diophantine equation. Alright, just in case, alright, I didn't cheat your feeling. A naught H plus B naught G equals to ACL closed loop, A closed loop. Same thing over here, A naught H plus VOG is equals to blah blah. Alright, so I'll just simply sub in A naught. A naught is where? A naught is this dude over here. This one is your S squared plus 2. So I'll just simply sub in S squared plus 2 over here. Alright, while your H over here, what is your H? Your H is S plus H1. So I'll just write it over here. Okay, maybe I should write in the small letter. Alright, plus B naught G. B naught is your 1. Alright, so this is B naught is equals to 1. Therefore, just write as 1 multiplied by your G. G is this one over here. Alright, because it's G of S. Alright, so therefore it's G1S plus G0 is equals to your ACL. Okay, just to double check, your order over here, S squared times S is S cubed. Alright, so this part over here, the highest order is 3. For this side over here, the highest order is 1. And therefore, if you compare, this is in fact 3, your highest order for your ACL, same thing as this one. Alright, now, know that the highest order for your ACL is 3. We can anyhow shoot one equation. Alright, how do we shoot one equation? Is that as long as it's to the power of 3 is alright. So it's somewhat like S plus 1, S plus 2, S plus 3 should be fine. Alright, and I just simply sub in my S value. Maybe okay, sorry, I shouldn't have say 1 S plus 1. I should say like s plus a, s plus b, s plus c. Alright, this is some of the general equation. Alright, while you can also sub in as more trim one, you can sub in as a complex system. Alright, this is the complex system. This is like s plus a, something like that. So where your a is equals to your minus a plus jb. Alright, so it's some complex system instead of a real number. Alright, so later on you'll deal with this. So don't think that you'll not deal with this. Alright, that's just let you know only. Alright, so therefore you have some difference in your, so you can write this, because if you multiply them all together, s times s times s, the highest order is still 3. So you can still use this equation. So therefore you can use any equation as long as the third order can already. But because we have our design criteria and things like that, so for example in our case now, which is the proper system, alright, we want our where's me? Yeah, hold on a while. Okay, so in this case our design criteria states that you need to use this equation, alright, and multiply. So this equation is the post of your general equation, if you still remember from the control side, the general equation for your, I lost my data, but just take note, this is some equation for your second order transfer function. Alright, so it's this one over here. Alright, it's a general formula for your second order response. Alright, your closed loop response, as you can see, is a closed loop response, second order. So we take in we often know that what we're doing is always dealing with the closed loop post, right? So therefore the closed loop post for your second order response is this dude over here, and therefore we'll just plug it out. And therefore where we have to go in now, where are we now? Is here. Alright, so this thing over here is second order only, but we are dealing with 3 order because that's what we calculated just now, right? Our ACL must be equals to, where am I? Must be equals to 3. Alright, and therefore instead of using this equation, my general equation now is what I've shown you just now. Is this whole thing over here. So I simply sub in any s plus p. Okay, and therefore how do you solve these things? How do you acquire a certain number? We say that the p is large. I don't know how large. It can be larger than China, it can be larger than last year, but anyway, some large number. I don't know how it came from. Boom, right? Just come naturally. I'll just briefly go through. Alright, omega n, your natural frequency is, if you still remember, is equals to the 2 pi over the, what's that called? Your frequency. Is it? Shit. Never mind, I don't know what's going on. But still, this is your natural frequency. There is some formulas to govern. That's why we have not enough adequate information. That's why I cannot do anything. Or the damping factor is somewhat the 2m some c, if you still remember, there's some equation for the damping factor. Alright, so damping factor is this equation. Alright, then you sub in within this value, so you know your natural frequency, you know your damping factor. Maybe you should know that maybe this may be 5 and this may be 10, and then you just sub in the values and then you multiply with your s plus p. Well, I don't even know where the hell is the p. Why? I don't know. Then you just sub it in, you eventually solve for some values over here. Alright, so you are solving for a general equation, and then you just sub in over here. Alright, and if you still remember just now, we safely derive our stuff over here naturally, right? Still nothing goes wrong, right? Because if you have to just take a look, this is the same thing that we derived just now. Where am I? Yeah, it's this one over here. Okay, this is exactly the one that we've derived. Alright, if we just double check. Alright, exactly the same thing, s squared plus 2 over here. Alright, so once you solve for this thing over here that we have derived, you have these things over here. Alright, which is some g0 or h0 or whatsoever. So you compare your values with this value that you have found, and then you can simply sub back into your this equation, and that's it. Alright, for example, this is like h not, this is maybe g1 for example. Alright, so this is 5, this is 3, this is 2 after you solve. So your g0 is equals to 5, your g1 is equals to 2, and your h0 is equals to 3, for example. Alright, so just simply sub back into your equation, your general equation for your controller. So in this case, G1 we know that is 2 over here. Alright, so therefore it's 2s plus G0 is 5, and then s plus h0. So h0 is 3, so it's just s plus 3, and therefore this is your equation for your controller. Alright, for a proper controller. Alright, because we are talking about proper controller. Alright, proper controller with its proper so-called criteria to follow. I think I have no time to go through the strictly proper, so I'll see you in the next video for the strictly proper video on how to solve this same equivalent equation later on. I shall see you there.